All right, hi everyone. Today we are working on graphing parabolas. That's right, graphing parabolas. We'll relate that to graphing lines and some ways that we can actually graph faster. Okay, and why don't we want to go the slow way? Let's go ahead and talk about it. So if we say y is equal to x squared, that's our first starting graph. And is there a fast way for us to graph these parabolas? And is there a pattern? And there is. Let's go back to lines. Thanks, Sarah. If we say y is equal to 3x plus 2, this is the graph of a line. And the way we know it's a line is because it's not x squared. It's not fancy. It's just regular x. Okay. As x changes by 3, right, the y changes by 3. If x is 1, we're 3. If x is 2, we're 6. If x is 3, we're 9. See, it's changing by 3 every single time. And then we said that is our y is equal to mx plus b form. As long as we knew the form, this is our slope. And the b value turned out to be what we call the y-intercept. And this allowed us to kind of cheat. It said, start at the b value, that's where we start, and then we rise based on the slope. So in this graph here, let's go ahead right on the right side here. My y-intercept b is equal to 1, and my slope is 3, and we call it 3 over 1, because it's always rise over run. So at y is equal to 2, 1, 2. I'm going to go ahead and mark this with red here. I'm going to put a dot here. Okay, that's my y is equal to 2. And then how do I get to my next point? Well, it grows 3 steps at a time. 1, 2, 3 over 1. Right? And then we're going to draw a nice line here. Do, 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 do. And this keeps going. And guess what? It follows the pattern of 3 over 1. If I go up 3, 1, 2, 3 again, and over 1, 1, 2, 3 over 1, it's the same exact pattern through the whole graph. It's a constant growth rate of 3. It's like you getting allowance every week, and that's how you get $10 a week. So one week you get 10, the next week you have 20, the third week you have $30 now, right? You're getting $10 a week. It's increasing by the same value. Now parabolas though don't increase by this nice constant value. They're squared. So can we come up with a pattern for us? Now let's go ahead and get started. First thing, let's take a look at, let's set up a graph here. And then we're going to set up a table for us to start, because that's a method that we learned before. We worked on tables, x's and y's. And hopefully your homework didn't seem like it was that hard. And 0, 1, and 2, and 1 and 2. Negative 1, negative 2. And this x squared pattern is going to be for all parabolas. All parabolas are going to pretty much have this basic form. So if I put 0 squared, right, if I plug in 0, 0 squared is what? Then what is 1 squared? And then what is 2 squared? Okay. How about if I go the other way? What's negative 1 squared? What's negative 2 squared? It's almost like I'm doing standards here, right? I will, not, take. So now I can do the math. This is going to be negative 2 is going to be positive 4. Negative 1 is going to be 1. 0 times 0 is 0. 1 times 1 is 1. And 2 times 2 is 4. Now, you'll see this pattern for all parabolas that have the standard growth rate of 1. And you'll see that 1 step over means 1 step up. What about 2 steps over? What's 2 squared? That's 4 steps up. 1 step over means 1 step up. 2 steps over mean 2 squared is 4 steps up. And that's our general pattern for all our parabolas. Well, let's graph that. If we're right in the middle, 1 step over means 1 step up. 2 steps over means 1, 2, 3, 4 steps up. And I tried to point this out last time that these 3 points look like they're in a straight line. They look like they're in a straight line. 1 step over, 1 step over, 1 step up, 2 steps over, 2 squared is 4 steps up. Okay, so please remember, 2 steps over is 4 steps up, 2 steps over is 4 steps up, 1 step over is 1 step up. Okay. Now, this looks like, again, it looks like these should be in a straight line, but are they? It turns out they're not. And as x gets bigger, when you square a number, it grows faster. Like 1 squared is 1, easy. 2 squared jumps to 4, 3 squared jumps to 9, 4 squared jumps to 16. You went from 9 to 16. 5 squared becomes 25. You went from 16 to 25. So you're increasing super fast. And by the time you hit 10, you're at 100. In 10 steps, you reach 100. That's really fast. So these squares increase in this pattern of me just squaring it. And you're going to try to draw a parabola here. Okay. Now, how would this graph change if I throw a number in front of it? Now, if I write y is equal to, let's say 2x squared. What happens when I say y is equal to 3x squared? What would happen to these numbers? Now, if I show you a simple table, let's do a table. Actually, I'm going to try to squeeze it all in one paper here. X's and Y's. I'm going to plug in the same numbers. I'm going to 0, 1, and 2, and -1, -2. Over here, I'm going to throw a 3 here. 0, 1, and 2, and -1 and -2. Okay. Now, what happens? This is just a 2x squared, 2x squared, 2x squared, 2x squared, and 2x squared. Do you see how I just stuck a 2 in the front? On the right, it's going to be 3x squared, 3x squared, 3x squared, 3x squared, 3x. Oh my gosh, it feels like I'm doing standards. Equal, 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 equal. So I'm just trying to make sure you guys see this pattern. Now, do those numbers change when I plug in 0? 0 squared is still 0. 1 squared, -1 squared is 1, but 1 times 2 is now 2. And 2 times 2 is 4. -2 squared is 4. 4 times 2 is now 8. This is 2 and this is 8. I want you to see what happens between our original problem when it was an invisible 1 here versus when I stick a 2 in it. Does it do something weird or is it kind of predictable? We went from 0, doesn't change, but 1 became 2 and 4 became 8. What happens when I multiply by 3? That's 0, 1, 2, -1, -2. 0 times 3 is 0. 3 times 1 is 3. 2 squared is 4. 4 times 3 is 12. 3 and 12. How do these numbers change? So if I multiply by 2 or I multiply by 3, you'll see that it's still the same pattern, except I'm going to multiply it by that new number in front. So if there's a 2 in front, all the numbers are double. Yay, I won the lottery. If the number in front is a 3, I've tripled. I won a triple lottery, I guess you could say. So when your mom says, I'm going to double your allowance, your $10 a week becomes $20 a week. So you go from 20, then 40, then 60, because I'm going to double all the values. What if I triple your allowance? You go from 10 to 30, then from 20 to 60, and from 30 to 90, right? So we're tripling all our numbers. So how does this play out in the graph? Now you might say, it seems like I'm going to have to graph a lot. Answer is no. And here's the basic pattern. If you know where the vertex is, if you know where the center of the graph is, if you know where the center of the graph is, and the center for us here is going to be 0, 0, 0, 0, okay? 0, 0. I want to show you how fast we can graph parabolas, and just with 3 points, because the rest of the points are way too far away. If we take one step over, we normally go one step up. That is our basic parabola. A parabola with 1 means you grow one step over, one step up. Everyone okay with that? One step over, one step up. 2 steps over, 4 steps up. 3 steps over, 9 steps up. 4 steps over, 16, because I'm just squaring it. But for a basic parabola, take a look here. It's going to be super easy. If you can catch this, you're going to do the homework in like literally minutes. Like, sorry, it's always minutes, but really short. If I take one step over, we don't take one step up. We take times 2. 2 steps up. If I take 2 steps over, 2 steps is usually 4. 4 times 2 is 8. See how we're 8 here? Do you really want to graph 8? It's too far. Just make sure it's really skinny. 2 steps, 1 step over, 2 steps up because we doubled our speed. Over here on the right, how fast did we change our graph? We tripled our speed, right? So from 0 to 1 step over normally is 1 step up. So tell yourself, normally x squared is 1 step up. But since I tripled your speed, it's going to take 1, 2, 3 times now. super skinny. 1, 2, 3. Now, I want to show you guys, and Desmos here. Hopefully I have it here. See if it's here. Oh, no, let me go find it. Okay, so what I want to show you guys here on Desmos right now is that I have my equation. It looks like a parabola right here. And when A is 1, take a look. Are you guys okay with 1 here? If A is 1, we have a parabola. 1 step over, 1 step up. Right, 1 step over, 1 step up. And we're at 1, 1 here. Come on, let's go. 1, 1. Okay. But what if A was 2? If I double the graph, so we take 1 step over. 1 step over means 2 steps up. Okay, and that's in both steps over, both ways. 1 step over means 2 steps up. What if we were A is equal to 3? One step over means 1, 2, 3 steps up. 1 step over means 3 steps up. And that's what I want you guys to realize with these easy parabola problems is that if we know where the center is, if I take 1 step over on either side, we can graph this parabola pretty darn easily. What happens though? What happens if this was negative? Let's take a look here. If I put A negative, -1, the parabola jumps down. But by how much, and is it predictable? Let's take a look here. Our parabola is 1 step over, but instead of positive 1, we are 1 step down. 1 step over, 1 step down.
What's that?
Okay, what if it was 2 steps over? If it was 2 steps over, 2 steps over, is this predictable? 2 steps, 1 steps over would be 2 steps down. So this is our pattern. If we know what the A value in front of our x squared graph is, we know how this is written. We know automatically how this is graphed. Because let's go take a look at your IXL problems today. Today, you guys are working on IXL. This is at 55, BB5. Now, if you look here, this is 6x squared. So x squared, we're going to be right at 0. Okay, and we'll talk more about that later, how to figure out where the center is. X squared. Now, how will this graph be drawn? 1 step over, what's my number in front? 6. We know 1 step over is 1, 2, 3, 4, 5, 6. Man, I'm making a lot of money this week. My allowance got multiplied by 6. That's it. I see 4. 1 step over, 0, 0. 1 step over, oops. 1 step over, positive 1, 2, 3, 4. That's how fast these graph parabolas are if you understand the pattern. And the pattern is 1 step over, 1 squared is 1. 2 steps over, 2 squared is 4. Oh, I'm increasing. 3 steps over, 3 squared is 9. Great. But then if I stick an A value, I'm calling the A value here in front, we just multiply that first step by that number. One step times 4 is 4 steps up. 2 steps is 4. 4 times 4 would be 16. I'm not graphing 16. That's way off this chart. Let's look at another one. Oh, negative. Okay, that's a negative invisible 1. From 0, 0, 1 step over, 1 step down. Okay, so negative means we're going to be facing downward. And the cool thing that A value tells me how much I'm going to go up or down. 3, center, 1 step over, 3 steps up. Okay, so we can kind of figure out where to put these dots to help me keep this graph nice and easy to work with. Now, what if I start including numbers on the outside? So let's go ahead and go back and talk about the main form. Just like lines have y equals mx plus b, we have a master equation for parabolas, and this is what we call vertex form. And vertex form is y is equal to a x minus h squared plus k. And this is where we're going to spend most of our time now. We don't have that much time left, but this is that big equation like y equals mx plus b. Remember, we have y equals mx plus b, and that became easy to use. Our parabola equation, a x minus h squared plus k, where h and k, h comma k. Please notice that this is negative, but this is not negative, okay? So we're going to talk about how do we deal with that when it's not negative. Is what we call the vertex. This is my vertex point. Vertex at h and k. So If I give you a problem, I can tell you automatically if it's in this special form where the center of your parabola is. No more guessing around. So let's give you some examples. If I say y is equal to x minus 3 squared plus 2, and y is equal to x minus, let's do a 5 here, 5, x minus 4 squared minus 1. What would be the h and k for each of these? Now be careful, I'm gonna ask you for 3 different things right now. What is the a? What is the h? And then what is the k? What is the a? What is the h? And then what is the k? Let's see if you can parse that out. Now remember, the negative is already in the problem. So when you pick your h, you have to remember that the negative is like it's built into the wall. You can't take it with you. So in this case, the a is an invisible one. Invisible one, right? Okay. My h value is a positive 3. And my k value is positive 2. Now I want to make sure that you guys see why this is true. If I ask you to fill out this blank, y is equal to a, x minus h squared plus k, 1 is a, h is 3, and 2 is k. Do you see how that negative sign makes the 3 negative? Okay, that gives us back our original answer. I don't want to take the negative with me. It already belongs there. So be careful here. Let's look at the next one. A is 5, h is 4, right? Because of negative, we leave the negative, and the k is negative 1, because k has to be positive. The formula starts off with it being positive, so you brought the negative with you. Take the trash out with you. You brought trash, you take it out with you. Okay, this negative here, the trash was already there, so just take yourself out. Now, why is this super helpful? Is because I can tell you where the graph starts now. If my vertex is hk 4, negative 1, it's 4, negative 1. So 1, 2, 3, 4, negative 1. That's the vertex. That's the center of my graph. Super easy to find. On my left, what's the vertex of this graph? H and k. Oh, Mr. Code, negative 3. No, it's not negative. Remember, the negative is already there. The h is positive 1, 2, 3, and the k is positive 2. That's my vertex. And this is at, again, 3, 2. And this one over here is going to be 4, negative 1. Now, which way would the parabola go, up or down? And that's the a value. That's the magic of the a value. It tells you which way and how fast. That's the one on the left. The a value is 1. So 1 step over means 1 step up. 1 step over means 1 step up. We have our parabola all done. That's how fast we can graph parabolas. Like no joke. That's it. That's the pattern. That's generally what the graph will look like. On the right, the a value is what? Positive 5, right? Oh God, that seems like a lot of work. But it doesn't matter. 1 step over means 1, 2, 3, 4, 5 steps up. To left, 1 step over means 1, 2, 3, 4, 5 steps up. And this will be actually 4, because it's 1, 2, 3, 4, 5 steps. We went up by 5 steps. So we end up from negative 1 to 4, not 5, because we start at negative 1. Put a dot. And this is a really super skinny parabola, because if someone paid me 5 times what I'm worth, bam, I'm rich. Okay, so if we have our h and k value, which will change our graph, sure, it changes the vertex, but we can automatically find out where to put that vertex value. Right, let's give ourselves another example. Maybe you guys are kind of on track here. Y is equal to negative 2x plus 1 squared plus 3. Okay, so please tell me find not just m and b, right? That's lines. We want a, h, and k. A, and the pattern is a x minus h squared plus k. And on the test, you should write that right on the top of the test, just to remind yourself. A is negative 2. That tells me this graph is going to go up or down. A hint right there, up or down. And then what is the h and k? Careful. A lot of kids, even as juniors, they mess this question up. Remember, it's supposed to be negative. So I'm going to rewrite this as, hey, isn't this a negative times a negative is a positive? So what happens is that actually was a negative 1, because negative is positive. So it actually was a negative sign there. That's a -1. So h has to be -1 so that the negative already there and the negative that you bring to it become a positive. And the k is a 3. Okay. All right, so let's go ahead and graph this. My vertex is at -1, 3. We just copy the h and k. So -1 is on my left and go up 1, 2, 3, put a dot. Great. So now we know where the center is. That's how fast it is. If you can identify the special parts of this equation, bam, we're almost done graphing. Now, the a value tells me it's a negative. So would that be facing up or facing down? Imagine if your mom put a negative multiply on your allowance. That means you owe her money for rent and food and clothes. I don't know. But 1 step over means 2 steps down. 1 step over means 2 steps down. We have our parabola facing downward. Okay, there are only 2 more things I need to show you, 2 more examples of this. What if I'm missing h or what if I'm missing k? Okay, what if I'm missing one over the other? So let's go y is equal to 3x squared plus 2 and y is equal to 3x squared, x minus 2 squared. Look at the difference in these two. Remember the parent function is y is equal to ax minus h squared plus k. Now, here's something I wanted to make sure you guys catch. If you have no parentheses, right? Yeah, no parentheses, right? No parentheses, it's because h is 0. H is equal to 0. That means we have no horizontal shift. So it's going to be a is 3, h is equal to 0, and k is equal to 2. Now, let me show you guys why. Let me write this in a different way. Maybe it's a little easier to see. It's 3 times x minus 0 squared plus 2. See, that's why it's 0 here. And what's x minus 0? That's just x. So that's the pattern that we're going to stick with. On the right here, it's going to be 3x minus 2 squared plus 0 because there is no k value. So we can write k as 0. So our a is 3, our h is 2, but our k is 0. And that's what we want to make sure we catch. These don't always look like what we start off with. It doesn't look like the perfect example, but it's because we have some zeros here. Okay. Another way of looking at this is just a regular parabola. Okay, here's a parabola, and it got moved up by 2 spaces, 1, 2. And that's what we're going to do here. We said our h and k was 0, 2. So 0, 2 spaces up, 0, 2. X is 0, y is 2. And then the parabola is 1 space over. Remember that 3? That 3 tells me how fast my first step is. How fast my first step is 1, 2, 3 spaces up. 1, 2, 3 spaces up. I always put 4 dots because I take 1 step over and then I go 1, 2, 3. That's why. That's why you see 4 dots. On the right, let's see where this one ends up. The h is positive 2. So 2, 0. And check it out. I didn't rise here. I'm still on the floor because there is no k value. There is no vertical shift for us. And then I'm going to go 1. So 1 step over. 1 step over. I'm going to go 1, 2, 3. 1 step over is 1, 2, 3. And we end up with this probably here. So 1 was shifted to the right. 1 was shifted up. So if you're missing an h or an x, it's almost like your controller is broken. You can only go either up and down or left and right because you're missing one of your axes. Now, if we can go forward to do a graph, can we go backwards to write the equation? Answer is yes. So I'm going to do only 1 or 2 examples of this one. Now imagine if I give you a graph here, and I give you some points, and these points are going to be, let's say 1, 1, 2, 3, put a dot. And then I'm going to say the next point is right here. Okay. I'm going to ask you guys to write this equation here. First thing, what is the vertex of this equation? What is the vertex of this graph? I'm sorry, what's the vertex of this graph? Would you be okay if the vertex is right in the middle at 0, nope, at 1, 3. So right away, we know that my h is 1 and my k is 3. What's the only letter left that we're missing? Well, we're trying to fill out the equation y is equal to a, x minus h squared plus k. That's the equation we're trying to fill out. So if I have my h and k, we're done with half the equation. We just need to find a. Now, how fast was this graph rising? Well, at one step over, didn't we just go up one step? And it's as simple as that. Now we have everything we have to write this equation. We just gotta make sure we plug everything in correctly. Y is equal to a, which is 1. X minus h, which is 1, squared, plus k, which is positive 3. If we have the characteristics written down, we can go back and write the equation fairly easily. So it's very similar to like us doing slope-intercept form, except we're now doing it with parabolas. We can tell you how fast it grows with that a value. It's not the slope. It's kind of like our multiply. It tells us how fast that parabola changes. And then we have the center of our parabola, very much like our b value. Our b value is our y-intercept. Our h and k value tells us our vertex, the center of the graph. Let's do one more of these real quick. I'm going to throw this on the other side now this time. To -2 and positive 1, 2, 3. The vertex is at -2, comma positive 3. You guys okay with that? And then I'm going to make this graph go like this. Oh, missed that one. Okay, and these are our big points. So to fill out our form, y is equal to a x minus h squared plus k. We want to fill out what our a value, our h value, and our k value is. So hopefully you can see that the h and k is given. That's the vertex, that's the center. That's just your h and your k value. What is your a value though? And that's always easily found by just taking that one easy step. If I take one step over, do we go up or down? When I take one step over, I went 1, 2 spaces down. That's going to give us a -2. Now we have everything we need. Y is equal to -2, x minus -2 squared plus 3. Now take a look here. I put a negative and negative. So we can change that. If you want automatically, y is equal to -2, x plus 2 squared plus 3. Okay. All right. So you guys are going to get more practice on that through IXL today, okay? You're going to go forward by drawing the graph and then go backwards writing the equation. And those are the two things you can practice. And once you get really good at that, the IXL, the BP5 is going to be up to 95 because I want you guys to make sure you can graph those really easily. And then going backwards is up to a smart score of 90. All right, that's it.